So good afternoon everybody, myself Acharya Vishvendra. Let's discuss NCERT line to line questions. The chapter is chapter 9, Mechanical Properties of Solids. So let's start with that. The first question is, a rigid bar has a rigid bar, so it can be deformed by applying forces. Next is, shape or size of a body can be changed by, obviously by forces. Third is, elasticity is tendency of body to regain its shape and size. So first is correct over here. Next is, plasticity is no tendency to regain shape and size. So second will be correct over here. Next is, examples of ideal plastics are closely. So both putty and mud are close to ideal plastic. So option 3 will be correct over here. Next is, which of the following is brittle? So glass is brittle, whereas brass is not brittle. So first is correct over here. Next is, in solids, atom or molecules are surrounded and they are bounded by interatomic as well as intermolecular forces based on what type of solid it is. So third will be correct over here. Next is, elasticity is due to, so it is due to unbalanced intermolecular forces. When the equilibrium position of the atoms holding a solid are disturbed, then they orient themselves in a way so as to achieve minimum energy state. So second is correct over here. Next is, according to Hooke's law. So Hooke's law states that stress is proportional to strain. So elongation is proportional to law. Next is, deformation produced in a body depends on applied force, nature of the body, both. So it depends on both. So third will be correct over here. Next is, the restoring forces. The restoring forces developed in an elastic body is equal in magnitude to the applied force. That is correct. And is opposite to the applied force. That is also correct. So third one will be correct over here. Next is, dimensional formula for stress. So stress is force by area. So you substitute the dimension, it comes out to be m1 l minus 1 t minus 2. Third will be correct. Next is, SI unit of stress. So that is Newton per meter square. Next is, CGS unit of stress. It is Newton per centimeter square. Next is a graphical question in which area is constant and variation of stress with force is asked. So as we know that stress is equal to force by area. Area is constant, so we can say that is stress proportional to F. So graph will be a straight line as given by the first curve. Next is, for a constant force, stress with area of cross section. So obviously for a constant force, stress is proportional to 1 by area. So graph will be a rectangular hyperbola as shown by curve 3. Next is, a solid may change its dimensions under external forces in how many different ways? So generally there are 3 different ways. So there are 3 ways. One is longitudinal, another is tangential or shear, and third one is volumetric. Next question is, a cylinder is inacted upon by the 2 forces. The stresses, obviously they will be tensed. I will try to stretch it out. So the stress here is the tensile stress. However, in this question, stress is compressive stress. Next is tensile and compressive stress are example of, so these are longitudinal stress. Next is dimensional formula of strain. So strain is change in length by length, so that is dimensionless. One is correct. SI unit, it is unitless as it has no dimension. Next is length of cylinder changes by x. If L is the original length of the cylinder, then longitudinal strain is. So this is change in length by original length. Here L is in centimeter, so that will be x by L. Next is restoring force, tangential force per unit area gives, so tangential force gives shear stress. Next is Boylian air pump was constructed by obviously Robert Boyle. Second is correct. Next is shear strain is, so this is equal to x by L. One is correct over here. Next is when a solid is placed in a liquid, stress on it due to pressure are called, so this is called the hydraulic stress. Next is ratio of hydraulic stress and hydraulic pressure. Obviously it is equal to 1, both are same. Next is volume of a sphere changes by delta V. Then volumetric strain is, so this is delta V by V. Next is according to Hooke's law, so first is correct, stress is proportional to strain. Next is graphical representation, so graph will be a straight line as given by first curve. Next, Hooke's law is valid, so it's valid only for a certain limit or for small deformations. Next is we are being given a graph over here, and we need to tell point A represents, so this is a proportional limit. Up to this limit, Hooke's law is valid. Then is there point B. So point B is the yield point. The physical significance of B or the yield point is that, and this is also called as elastic limit, because if you apply a force such that strain extends beyond B, then there will be a permanent deformation as given by point C. So point C represents permanent set or permanent deformation, so one is correct. Next is point D represent. So you can analyze from the graph that point D corresponds to the maximum stress, so it is called the ultimate stress. In fact, point D here is the ultimate tensile strength, so given by second option. Next is E represents fracture point, so third is correct. Next is material is said to be brittle, so brittle materials means it gets broken down easily, so if the points are closer, so that is called a brittle material. Next is material is said to be ductile, so it is said to be ductile when the points are far separated. Point 2 is correct. Next is stress strain curve for the elastic tissue of water, so it's a curved graph, basically a parabola type. Next is examples of elastomers are, so tissue of aorta and rubber both are examples. Third is correct over here. Next is ratio of stress and strain is called, so that is called modulus of elasticity. One is correct. Next is here modulus of elasticity is being asked. So modulus of elasticity is the ratio of stress by strain, and you can see over here that stress by strain will correspond to, this is the stress and this is the strain, so in the right angle triangle it is equal to tan theta, which is P by B. So third is correct over here. Next is dimension formula, so it has same dimension as that of stress given by 2. SI unit same, Newton per meter square. CGS is dyne per centimeter square. Second is correct. Next is Young's modulus is the ratio of, so Young's modulus is basically the ratio of longitudinal stress and strain.